Okay, let's get started with chapter 2. We'll work on section 1 first, and I think I'll split it section by section. We skip sections 2 and 3, I believe. Yeah, we skip formulas and applications. So the first video is going to be section 1, and then I'll jump to section 2-4. So for this one, it starts out on page 107, and they give us some definitions and some properties. Let me switch the screen. And I wrote these out first. The solution set, they give you the technical definition, but when they talk about a solution set, what that refers to is answers, basically. How many values, when put in place of the variable, result in a true statement. Any of those are correct answers. Then they go to the addition property of equality, which is on page 108. And what they say with this is, if you have anything on the left equal to anything on the right, so any quantity, any group of terms, if A is equal to B, then as long as we add the same amount, they say C for the property, if we add the same amount to both sides, then that statement remains true. Solving equations, I like to think in terms of like a balance. And what you need to do is make sure both sides stay balanced. So if you add C to only the left side, it's going to drop. There's going to be more over here. You've got to add the same amount over to the right to balance it out, to even it out. So the same is true for the multiplication property of equality, where if you have anything on the left equal to anything on the right, two quantities of any kind that are equal, then if you multiply those quantities by C, they don't use parentheses, but I'm going to go this route. If you take any quantity on the left that's equal to a quantity on the right, if you multiply by some other quantity on both sides, they still remain equal. It just has to be the same amount on each side. So that's what the properties are telling us. Again, I don't test you or quiz you on definitions of the properties or theorems. I just want you to know what they mean and how to use them. Now, page 109 in the textbook, that brings up a key method. They call it method 2 when solving, when working with fractions. Their method 2 is my go-to, and it's what I suggest you do. Fractions are one of the biggest issues for students. So what I suggest is make them go away. Method 2 says eliminating the fractions at the beginning, and they give us an example. They give us 2/3 x plus 1/2 equals -3/8. And now what they're doing is they're looking at the denominators, and they have, well, I don't want to do it that route. They have 3 as a denominator, they have 2 as a denominator, and they have 8 as a denominator. The goal is to find the LCD of all of them. Figure out what the least common denominator is with everything on both sides of the equal sign. You've got to apply this to every single term they give you for this to work. Now, we know 3 and 6, or 3 and 2 will go into 6, but we have an 8 here. The way I like to go is I always take the biggest number, and if nothing divides into it, I multiply it by 2, and I get 16. Well, 3 doesn't go into 16, so I multiply by 3, and I get 24. So 2 goes into 24, 3 goes into 24. 24 is actually my LCD. So if I were changing these fractions, I could add them all together. I could manipulate them if I make them all equivalent fractions out of with a denominator of 24. Now, the way you make the fractions go away, I'm going to split it up, I think, more than the book, probably. No, the book does this. So you're taking your 24 and multiplying it by, I started with 24, so I'll keep going this route, multiplying it by every one of those. This will make your fractions go away. The reason being, when you're solving, you're going to end up flipping anyway. So if you have the same denominator, you will do a reciprocal at some point, and you'll end up multiplying by that denominator and they'll cancel out. We just do that in the first step. So 3 goes into 24 8 times, and then 2 goes into 24 12 times. I better do parentheses so you see what's going on. And then 8 goes into 24 3 times. And then you are left with 8 times 2 is 16 plus 12 equals -9. And you can easily solve that. You get rid of the fractions. People hate fractions, make them go away. If you don't like fractions, make them go away. Again, I mentioned in an earlier video that fractions are just 2 numbers. Typically, complex fractions are different, but a fraction, you have a numerator and denominator. Focus on each number instead of confusing it by thinking of it as fractions. So you can make them go away when you're solving equations. Okay, and then how to solve equations in one variable. On page 110, they give you a how-to. On page 111, they discuss solving equations by factoring. And then they give a definition for quadratic equations. Quadratic equation is just anything that can be written with an x squared, basically. Think of it that way. They give you the definition ax squared plus bx plus c equals 0. You just understand that. You don't need to know the definition. And then zero factor property, we can do that right here with this one. When they talk zero factor property, they mean we need to set equal to 0. We want this equal to 0. How do we make it equal to 0? We add 9. Again, if we add 9 here, it goes away, we get 0, but we have to add 9 to the left to keep these balanced. So add 9 here gets our 0, we add 9 here. And we end up with that. That would be what they mean by 0. And it doesn't work here. I just use this for an example. Here we're going to move that back anyway. Oops. Here we're going to end up moving that back. But I wanted to use this one as an example for what they mean by when they're zeroing out an equation. We'll do that with quadratics when we have an x squared. Let's just get to, oh, and then they give you solve an equation by factoring on page 112. This will make more sense once we get into the actual example. This one, I guess we should do this. This one we would have solved by going ahead and moving the 12 over. We had a -9 over here. We're going to subtract 12 from each side. I don't want to leave anybody hanging with this one because I'm pretty sure the book finished it out, so you can go ahead and follow. Yeah, you can follow their mode of thinking, but I just jumped ahead to show you what they mean by equaling 0, setting equal to 0. So we would just divide and get -21 over 16. What I want to mention here, I should have mentioned it in chapter 1. In algebra, we don't deal with mixed numbers. We're solving for x or y or z. We want to solve a variable. Once you solve it, you leave it, even if it's an improper fraction. Don't worry about it. If it's improper, leave it. This is an improper fraction, but we're leaving it because we have 1x. The goal was solve for x. I did. So in algebra, we get to leave improper fractions. Okay, so to problem set 2-1, I want to do number 11 because that throws people off sometimes. There's a couple steps to take. The first step, set equal to 0. Whenever we have an exponent involved, we need to set equal to 0. If we're just solving for a single variable, then we can do what we did in the example and just move over and divide. But when we have multiple variables, exponents, we need to set equal to 0. So we set equal to 0 by getting rid of 1. I like to think of keeping the high degree positive. Move whatever's going to keep your highest degree exponent positive. My 9a cubed, that's positive. Positive 9a cubed. So I'm going to move this one over here. I do so by subtracting. I subtract 6a or 16a from both sides. Once I subtract 16a from both sides, I get a 0 on the right and negative 16a's on the left. Now, always remember the orders that we want to go in when factoring. Number one, look for a greatest common factor. Doesn't always happen. They're not always in there. But if so, it's going to simplify the process. If not, you will get a wrong, most likely get a wrong answer. So all I can pull out of this one is an A. When I pull out an A, I'm pulling an A out of an A cubed. I'm left with A squared. And then over here, I'm left with 16. So first, you want to look for greatest common factor. Second, double check to see if you need to group. There aren't 4 terms. We only have 2 terms, so we don't have to group anything. Now, that leaves us with, I'm going to rewrite it here so I give myself more room. Leaves us with the next step of look for special factors. Do you see any perfect squares or perfect cubes? I do see a perfect square. I'll spend a little time on it now. As we move forward, I'll just say there's a perfect square and work it out. Our perfect square is 9a squared. I have the square root of 9a squared is 3a because 9 is 3a squared. A squared is a squared, obviously. And 16 is 4 squared. So there's our perfect squares. I have a perfect square minus a perfect square. I know there's a special rule for that. The special rule for that is a plus b, a minus b. So I take my 3a because my square root of 9 is 3, square root of a squared is a, square root of 16 is 4. So I have 3a plus 4, 3a minus 4 equals 0. Now in this case, we're actually going to have 3 answers for number 11. It's another reason that people get thrown off. Oh, I don't have my green, shoot, I forgot my green pen. So every time you have a variable outside of the parentheses, you're guaranteed one answer is 0. That's one option. If a equals 0 here, it doesn't matter what this is because 0 times anything is 0. So we have 1 already. Then when we get these problems, you'll learn to look at these, hopefully. Look and know that you will have the opposite to make this 0. You have a 4 here. To get the opposite, you would move it over. You're going to have to divide the 3a by 3. You're going to end up with one possible answer of negative 4/3. And over here, you're going to have the opposite. You know it's going to be positive. You're going to have a 4. You have to divide the 3a by 3. So you're going to have a positive 4/3. There's your 3 answers. Just to make sure everybody's following along, I'll show you what I did. You take every quantity and set it equal to 0. Because if this is 0, the whole thing's 0. If this is 0, the whole thing's 0. If this is 0, the whole thing's 0. Doesn't matter how many there are. You have to solve each quantity. How you solve is set it equal to 0. And in this case, I would take 4 away here and move it over here. And then I would divide by 3. And I'm left with a equals negative 4/3. That was this one. And then I'll just go ahead and do this one real quick. If we had the 3a minus 4 equals 0, we have to move over there because we want to isolate the variable. I'm sure you've heard that before. Isolate the variable. And then we divide and we get a is 4/3. So there's our answers. Our answers are 0, negative 4/3, positive 4/3. That was number 11. I'm going to do number 39. I think I can fit all these on one. Now for 39, they're just saying each equation appears later in the book, solve each equation. So we're just going to solve the directions they give us, solve the equation. 39 gives us 15 minus 3 times x minus 1 equals x minus 2. Okay, now back to square one at the very beginning, order of operations. This is a big key. We have to know order of operations because some people will end up subtracting 3 from 15 and multiply 12 and get the wrong answer. That 15 does not apply yet. We have to distribute first before we can do anything with that. Our x minus 2 over here is just kind of lingering. So we're going to wait on that to see what we end up with here. I need to distribute my negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 3, and that's x minus 2. Now, it doesn't really matter what route you go here. I'm just going to combine these so it looks a little cleaner. I have a negative 3x. I have a 15 plus 3. So I have 18 equals x minus 2. What I suggest, because it will help later in the chapter, or later in the book, what I suggest is shooting for a positive variable when you have to move variables anyway. You have to move numbers around anyway. You might as well just look for a positive variable, then you never have to divide by a negative. And dividing by a negative is just one extra step you have to worry about. And sometimes we forget to write a negative, and then we get the problem wrong because we divide by a positive. So what I do is look for, how do I get a positive variable? If I subtract x over here, I have negative 4x's. I don't want that because I'm going to have to divide by a negative 4. So if I move my x over this way, if I add 3x to each side, then I'm going to end up with, I'll just write it out. If I do that, I'm going to end up with 18 on this side. I'm going to have 4x's here minus 2. Okay, I'm going to skip some of these steps later, but not right now. So now I need to move the whole number over here, which gives me 20 equals 4x. Then I get to divide by a positive. I don't have to worry about a negative. If you keep that route of thinking, that mode of thinking, then you don't have to worry about dividing by a negative. And I like that. I like moving the variables to get positive variables. It eliminates one headache, and I like eliminating headaches. That's why I multiply by the LCD to get rid of fractions. Get rid of the headaches. That was 39. Now we'll go to 47. Solve each equation if possible. They throw if possible in just to let you know there could possibly be a no solution problem. Those are the worst. And again, why I assign odd problems, so you can double check and not beat your head against the desk. Okay, so I'm not going to touch these yet, but I'm going to distribute my 3. And I get 3x plus 12. Now, what happens here is no matter where I go with this, I'm going to end up with a 0. And we'll go, I'll take it away here so you can see. We'll go this route. Doesn't really matter which side you go. Right now, I have 0 minus 6 equals 12. And I would add 6 over here, and I would get 0 equals 18. This is the last one we're doing, so let me go this route. If I went the other way, and I took 3x over here, you'll realize it doesn't matter. It gives us the same thing. And you could go this route and get negative 18 equals 0. It doesn't matter which way you go, you're not going to have a solution. That's a null set. They probably write null set. No, they just write no solution for this one. There isn't a solution. Now, if you, in the future, if you get 0 equals 0, then you do have a true statement. The key is looking for false statements. In this case, your variable went away, but you still had a whole number. 0 is not equal to 18, nor is it equal to negative 18, so there's no solution. In the future, don't get too quick to jump to no solution, because there's a possibility of having 0 equals 0 in a true statement. Okay, so that was section 1 of chapter 2. Maybe I can make the next section go quicker. I think this one was a little long. I hope you enjoyed it. I sure did.